JUVA wants you to know that retreaded tires are tires too. After 20 years in the tire business, JUVA knows what they're talking about. JUVA has been manufacturing retreaded tires since 2001, and in 2007, JUVA opened a second retreading factory using the very latest technology. In 2010, the JUVA company started close cooperation with Bandag, a member of the Bridgestone Group. Bandag is a well-known manufacturer of tire retreading technology and equipment. A modern truck tire retreading factory was established by JUVA in collaboration with the famous Austrian company Freiburg, which has been a recognized authority in the truck tire remanufacturing industry for more than half a century. The equipment manufactured by the Austrian company is highly automated, allowing the equipment to achieve the required accuracy in each process and to avoid the formation of harmful factors that could adversely affect the quality of the finished product. During the retreading process, each worn tire undergoes a number of recovery operations. Great attention is paid to quality control. During every stage of production, a visual assessment of the old tire carcass is carried out to determine any further restoration options, and the quality of the recovery operations is controlled by measuring equipment. If any defects are detected that may affect the quality of the retreadable tire, the carcass is not transferred for further processing. The high quality of retreaded tires is achieved by using the latest technology. Customers get only high-quality renovated tires. Our technologically advanced equipment accurately defines the cases when the tire is suitable for retreading and when it isn't. Firstly, the initial inspection of the tire is carried out visually, and this is almost the most important part of the process. At the present stage, it is determined whether the tire is suitable for retreading or isn't. Visual inspection includes inspection of the inner liner, inspection of the sidewall surfaces, inspection of the board edges, inspection of the external tread areas, and marking of the damaged areas. Critical defects can already be found at this stage of testing. The tire is strengthened on a special stand and observed visually. Foreign objects, such as stones, nails, and metal chips, are separated by a bodkin. If the tire passes the first quality control test, it enters the next stage. The defects which can be eliminated are being marked. It is obvious that the condition of the tire carcass most significantly affects the quality of retreaded tires. Therefore, it is important to avoid any mistakes by choosing valid frames for the restoration process. The JUVA company purchased Bandag computer-controlled laser diagnostic equipment, a chirograph, in 2010. It allows JUVA to analyze the technical condition of carcasses using laser beams. A vacuum of 1 atmosphere is created in the camera and the tire carcass is scanned with laser beams. This analysis is a non-destructive diagnostic method, and it allows identifying visually invisible stratifications, voids, and other hidden defects. Second, the old tire tread is removed and the surface of the tire is prepared for further vulcanization during the next stage of the process. This equipment looks like a tuning bench. The tire is inserted in the special socket and then it is inflated with air and rotated. A massive cutter gradually is separating the old tire's tread and forms the necessary shape, size, and roughness of the surface. This process continues until a perfectly round surface is created. The resulting surface texture will allow better contact with the new tread bandage. Processing is performed in accordance with the required profile, width, and radius, which depend on the overall dimensions of the tire and the type of renewable tread belt. These data are entered into a management system. Determination of defects is carried out also during this stage of production, although it should be noted that after the initial tests, the number of rejected tire casings is negligible. Defects hidden during visual inspection are often found after removing the old tire tread. Tire casings with unavoidable defects are discarded for recycling. Found defects that can be eliminated are being marked. Third, tire repair. Found faults, including cuts and perforations, are repaired. The tire is inserted in a special stand. Repairs of the internal and external surfaces are prepared by a technician. Damaged external areas are being cleaned and perforated sites are being sealed. Fourth, preparing for the tire vulcanization. Once the old tread and the layer under the tread is separated from the carcass, the layer must be renewed. The new intermediate layer material is necessary to provide stable adhesion between the frame and the new tread. Here, the tread part of the casing is being covered with a liquid rubber primer. Ground-out grooves are being filled with unvulcanized gum using a hand extruder. A belt made from natural unvulcanized gum is applied to the tire casing tread area, which in turn provides secure adhesion during further vulcanization. Fifth, preparing the tread bandage. At the present stage, it is necessary to cut the required length of the tread belt and to carefully prepare the joint edges. This guarantees that the tread patterns match. Sixth, applying the tread bandage. The tire casing is being placed in a special stand and inflated with air to a certain pressure. After the tire is inflated, the new tread is applied and is pressed against the casing. The prepared tire casing is inserted into the stand. Then it is covered with a special coating while a tube and rubber rings are placed inside the casing. The air is pumped out and the tread is fitted close to the casing. Afterwards, the casing prepared for vulcanization is carried to the next production stage by a conveyor. 8. Vulcanization. This process takes place in a special chamber, an autoclave that controls the exact time interval, temperature, and pressure. The required parameters are entered by an operator. Tire casings are inserted in heat-resistant covers and placed into an autoclave where the compressor provides adequate air pressure inside the tubes and the autoclave chamber. Pressure of at least 6 atmospheres is maintained inside the autoclave chamber to press the tread against the tire casing. The optimum temperature for this process is 100 degrees centigrade, which enhances the chemical conjugation process. Vulcanization of the natural rubber occurs, and the casing and thread of the tire become a whole. This process is called cold vulcanization, as the processes that take place at 100 degrees centigrade do not significantly affect the tire carcass or the cord piles. Tires can be retreaded several times using this technology. 9th, the final quality control check. Once the set of tires is removed from the batch autoclave, the final visual inspection is performed while the tires are still hot. However, if there has been any latent defects or any failure occurred during the retreading process, they are clearly identified at this stage. After a final quality control check, each retreaded tire is covered with a liquid gum and the tire looks as good as new after the treatment. All operations in all of the stages of the renewal process are carried out in strict compliance with technological standards. The statistics show that retreaded truck tires are fitted to more than 50% of trucks in the US and Canada, about 60% in Nordic countries, and 70% in the Czech Republic, as well as around 50% of the total truck fleet in Germany. Today, the characteristics of renovated truck tires meet the same requirements as new tires, but they have a very attractive price, providing substantial savings for transport operators. Tire carcasses that do not go through the xerograph are guaranteed for 1 year, but those that go through the xerograph process are guaranteed for 2 years and carry this special seal of quality. JUVA, now that's tires.